Morning. Mr. Lesham is here. Today, well, can I say just we finish all the different types of functions. So yippee for us. Well done. So we've gone through all the types of functions, all the type of graphs. And now what we're going to do is just do a few little things. Tie a few end looses, okay? But we're not dealing with one specific family. We could do it with all the families. What we're going to do today is quite a big topic, and that's called transformation, okay? So we've got a certain function. It could be a parabola. It could be an exponent. It could be a hyperbola. And we're transforming it, okay? In other words, changing it. It's the parabola still stay parabola. The exponent will still stay exponent. The hyperbola will still stay hyperbola. But we can do stuff with it. For example, what can we do?
I remember those.
What can we do? We've been actually talking about it, but we didn't call it transformation. Say again? We can?
There's a reflection.
There's a reflection. What's the thing though we've been doing a lot with parabola? Shift. Okay, so let's start with that. All the shifts that we can do, shift is basically move. Okay, keep the same shape but just move. Okay, there's two kind of shifts. Okay, you know what kind of shifts? What kind of shifts with? Yeah, vertical and horizontal. Okay, so if I've got a certain function, let's say f of x, I'm just calling it f of x. It could be any function. It could be hyperbola, parabola, whatever. And I'm adding a q plus a q. Q is a number. +3, -2. What kind of shift is that?
Vertical.
That is a vertical shift. Vertical shift. Okay? If q is, let's just write it down here. Okay? If q is larger than 0, like this. If q is larger than 0, which way is it going? Up. If q is smaller than 0, it is going sinking, is going down. Okay? For example, well, let's know. Shall we do example? Let's say we have y equal 2x. That's just a straight linear graph. Okay? If I go on and move to y equal 2x plus 1, then it's how can you describe it? What happens to this graph?
Goes up.
It goes up. Okay? Right. Let's look at this. Okay? If I'm adding a certain number, but not as a separate one, just to x. Okay? What kind of shift is this? Horizontal. Okay? That's going to be horizontal shift. Okay? And again, we have two examples. We're either going to have p larger than 0 or p smaller than 0. If p is larger than 0, this is where it's getting a bit confusing, but you know the answer. If p is larger than 0, let's say f of x plus 2. Where are we shifting this graph?
-2.
To the left. It's going to the left. Where if p is negative, let's say x minus 2, it's obviously to the right. Not obviously, but it's to the right. Okay? Let's look at the example. So if I have, let's say, y equal 1 over x. Okay? That's hyperbola, right? The mother graph hyperbola. If I change it into y equal 1 over x plus 1. Okay? What kind of shift did I do here?
Left shift.
It's a horizontal shift to the left. I took, let's draw this time. Okay? I took this graph, okay? That's a normal hyperbola, the mother graph hyperbola, and I shifted to the left. So now it's going to look like this. Okay? It's moved to the left. We happy with that? Okay, I'll just pause here for you to ask. Okay, the next thing I can do, let's actually go with the last one. A stretch or a squash. Okay? If I multiply a function by a number, I can stretch or squash it. Maybe we'll start with an example. So if let's say I have y equal x squared, which is our mother parabola, okay? And I now multiply this whole x squared by 2. So it's 2x squared. What did I do to the parabola? We've done that little hand movement quite a few times this last few weeks. What am I doing to my parabola? No, if I multiply by 2, I'm squashing. I'm making it steeper. Everywhere it becomes steeper. Okay? Everywhere steeper. So maybe let's just draw it like this. It goes from there to here. It's stretched. Well, depends which way you're thinking about. All these points are going up, so it's stretched in this way, but it's squashed on this side. Okay? Don't worry too much about the words as long as you know the picture. It all gets like this. So that's when I use an A larger than 1. If A larger than 1, we call it a stretch. Again, don't worry too much about the words. I'm not going to ask you is it a stretch or squash. Okay? It's not the big deal. Okay? It just goes up. If on the other hand A is between 0 and 1, for example, I can go from y equal x squared to y equal half x squared. Now it's going to be more flat, right? So that's, we're going to call that a squash, okay? So it's going to go this way, right? It's not stretched upward, it's actually squashed downward, okay? Now we've got one more case, and that is when A is negative. What happens when A negative? That's it. So beside the stretch or the squash, we also have a reflection. Okay? So we've got a reflection now. Okay? Reflect. Reflect over which axis are we reflecting? Over the x or the y? The x. Over x axis. And that leads us to this business. If I just take a function, let's take an exponent. We haven't had an exponent yet. Y equal 2 to the power of x. And now instead I slap in the minus in front of it. Y equal minus 2x. What did I do to it? Okay. I took it from an airplane going up to a ship sinking. No. Sorry? Yeah, it is. So it's like this. Yes, it is like that. It's just difficult to see. So I took it, maybe I'll draw it like this, one on top of each other. So I took it from...
Oh, I see what you mean.
Yeah, I'll draw it here. Yeah. You see it in this? Yeah. So I took it from an airplane taking up. Now I'm reflecting it over the x-axis. It's going to look like this. Okay? So by timing by minus, okay, I'm reflecting over it. If I'm just timing it, I can time by minus 2. It will reflect and stretch. Okay? So this is, what did we say this is? This is reflection over x-axis. Right. All the stuff that we've come across all of this. But there's one thing that, as far as I think, we haven't touched. What happened if you slap in the minus, not in front of the whole function like here, but just in front of the x? And I don't think we've done that. Okay? So I think what I'm going to do, I'm just going to pause here. I'm going to have to think how to do it. Okay, to try and understand what happens when we are doing this last transformation, which I'll write down here. From f of x, we're going to move on to f of minus x. I think we're going to do it in an example. Okay, because this is something we haven't done yet. And I'm going to use this example to spend a little bit of time on linear function, which we hardly did this year, but you still need to know that. So this is a linear function. What does linear mean? It's a straight line. Let's try and quickly draw a sketch of this linear graph. Okay? So what does this one tell me? It's the y-intercept. When x is 0, it goes through this point. 0, 1. I'm going to write it down here. Okay? When x is 0, I put 0 here, it goes through 1. That is the y-intercept. Now, this graph is going up or going down? It's going up. And how do I know that? How do I know that? Okay? Because A, my constant or coefficient of x is positive. This is actually the gradient of this equation. Okay? So it goes up. I can try and, with thinking a little bit, not too much, can figure out what this number is. What is the x-intercept?
It is.
Can anyone put it in their mind without
Minus
2?
Oh.
If I put -1, it will be -2 plus 1. It's a minus half. Rising star. Rising star. Okay? So when x is minus half, okay, so you guys let him see, huh? Come on. Minus half times 2 is -1. Did he steal your answer, Bruce? Okay. Okay, so this is it. Right. Now, I want us to understand, what does this transformation mean? I'm not slapping a minus in front of everything. What I'm doing, I'm writing another equation, okay? Let's take this equation, we'll call it g of x. I'll give it a different color. G of x is simply, I hope that's not going to kill you, okay? Is f of minus x. So I'm defining a new function where everywhere you have x, we're just going to put minus x. So let's do it. What is g of x really? I'm going to rewrite f of x, but instead of x, I'm going to write minus x. So what would it be? Instead of x, write minus x.
It will be minus 2x.
Minus 2x and the 1? Plus 1. The 1 doesn't change. The 1 doesn't change. All I did in this new function, this transform function, everywhere I had x, I put a minus x. So 2 times minus x is minus 2x. Can you see that? Now, how is this function going to be different to the f function?
It's going to become.
Let's start with the intercept. What about the y-intercept? Stay the same. When x is 0, it's still 1. So I'm still going to go through here. But now, are we going up or down?
Down.
We're going down. Going down, baby. Okay, we're going to go down like this. Okay? Now, if I say it now, I think you can figure out that this g function is similar to the f. I just did some kind of reflection.
Can I ask a question before you continue?
I'll pause, yes. So I'll come back to my question. I'm asking, what do I need to do to the blue line to get to the red, to the black line? Reflect over y-axis. So look at this blue line. If I reflect it along the y-axis, I'm going to get the black one. Okay? So I'm going to take you back here and use the example that we just did to realize that if I take a function and everywhere it said x, now it's going to be minus x, what I'm doing is reflection over y-axis. Okay? And what we'll do here is draw another example, maybe with exponent as well. Okay? You'll be less familiar with that, but I'll draw it anyway. Okay, let's have a function that is like this. Okay? Let's say this is y equal 2 to the power of x. If I want to draw y equal 2 to the power of minus 6, that's an example of taking a function and instead of putting x, I'll put minus 6. What's going to happen is going to be reflection over the y-axis. And you see that? I showed you an example with a linear, but it's true for everything. Whenever I put minus 6 instead of x, we're reflecting over the y-axis. Okay? I'm going to pause here and we're going to do some examples. So that was a lot to take in and a lot of theory. Now when I look at the kind of question that we asked you, there's two parts. The first part I think is relatively easy. The second part does require a little bit more remembering and understanding. But let's just get on with it. You are given a function. Okay, you told, look, I've got a function. F of x equal x minus 1 squared plus 2. What kind of function is it, by the way?
That is exponential. What?
Parabola.
Parabola. Exponential is when is the x in the exponent. Oh, okay. When you have x squared, well done, Gabby, is a parabola. So you got some kind of parabola. Okay. Now they're telling you, look, this f is transformed this f is transformed to g of x. And the rule of transformation, I'm giving you 5 different rules of transformation. What they're asking us to do is, first of all, to find what g is, and you'll see that's quite easy. And then write in words what kind of transformation it is, which is going to be tricky. Okay? Let's start with g of x equal fx minus 3. Guys, it's really easy. If f of x is x minus 1 squared plus 2, f of x minus 3 is simply x minus 1 squared plus 2 minus 3. As easy as that. That's all it is. Well, it's not all it is. What can I do with this? Minus 1. So I'm going to write x minus 1 squared minus 1. That's not difficult, eh? You just need to know what they're actually asking. Because I bet you the first time you look at it, you looked at me like you don't know what's going on here. Okay? All you got to do is that minus 3. Okay? So that's really easy. Everyone can do it. What's a bit more hard? In words, we need to understand what happened to here. But I think you can do that.
Went down by 3.
Perfect. But Bruce, you need to give a chance for everyone else, okay?
That's
You
what
can
I
see
always
what
say.
happened from here. You need to remember that if you're plussing or minusing a number, basically you're pulling it down or up. Because it's minus 3, so we're going to do, we call it a downshift, or shift down by 3. That kind of makes sense. That's pretty chill, right? Are we happy with that? Moving on. G of x is equal to f of x plus 2. You got to understand, because this is a little bit, not difficult, but it's new. We've never really done it before. Basically what this transformation tells you said, look, g is the same as f, it's the same of f. But everywhere it says x, now what must we write?
Plus 2.
X plus 2. So I've got x minus 1, then I'm going to write x plus 2 minus 1, and I'm going to square it, and I'm going to add 2.
So where did you get the minus 1?
There was still minus 1 there. It basically tells you, look, use the same f,
Oh.
use the same f, but everywhere it says x, please write first of all x plus 2.
Oh.
Okay? Originally it says x minus 1, now we're going to write x plus 2 minus 1. I'll just pause here to see if you're happy with that. Obviously we shouldn't leave it like that. We should carry on working, right? So what should we write? Yeah, you're right. X plus 1 squared and plus 2. Don't forget your plus 2. We don't need to expand it. Just like here, they didn't expand it. So we can leave it like that. Are we happy with that? All right. What kind of transformation that is?
I'm just saying.
It's a horizontal shift 2 then? By how much?
Left 2.
By 2. So we need to see, you know, I can write left or shift to left by 2. You need to say by how much. It's not enough just to say a shift left or horizontal shift.
The statement is done based on like the original.
On the original thing. You don't even need to do that.
Oh, okay.
Yes, you're absolutely right. So in words, the wordy bit, you don't even need to do that. You just look at that. But you need to remember that table that I wrote here. Most of it makes sense. So far, I think makes sense. Guys, please. Please. Okay, moving on here. Shall we maybe do the wordy bit before we do the function?
No.
Just to show you that you can do it.
Okay.
What happens if I say g of x is minus f of x?
Minus
The
x
signs
plus
might
2.
change.
Yeah, so what kind of transformation it is? You can look, it's a reflection, but you need to say which axis. On the y-axis, okay? When, you know, if you had y equal x squared, and now you say y equal minus x squared, you shift it, you're not shifting, you're reflecting it over the y-axis. So, reflection over y-axis. Yes, you want to ask something? C. C. Now, what is it actually?
X
No
plus 2.
problem. Well, I need to time everything by minus 1. So I'm going to write minus x minus 1 squared minus 2. I'll just pause here to see that you're happy with that. I'll just show you how I got there. This is the original f, right?
Yes, sir.
Now I'm timing it by minus 1. So now I can open this. I shouldn't really leave it like that.
Yes.
So I'm turning that into a minus. But then I have minus 1 times 2, which is minus 2. Okay, another question.